So for today, it is a little review of yesterday, and let's talk about sine versus inverse sine. Remember, this is how they look. No, this is not at all related to cosecant. I get how you might think that, but it's not. This isn't cosecant at all. Okay. So where did this thing first show up? The first time you ever saw this is when you had a triangle and you had like a 3, 4, 5 triangle and they asked you to figure out an angle. I'd like you to tell me an equation that involves cosine that would help you find that angle, the one at the top. An equation involving cosine that would tell you that angle. Did you say cosine of the angle is adjacent over hypotenuse, therefore 3 over 5? Raise your hand if you had that one right. Okay, awesome. Do you get that that could then be written this way? Inverse cosine on both sides, because inverse cosine cancels off cosine. And now I got theta equals inverse cosine of 3/5. That make sense? So this is an angle. When we figure it out with a calculator, it would be an angle. Let's not use a calculator. Let's just leave it that way. That's the way to say the angle that would be formed if the sides were 3 and 5 in a right triangle. All right, so that's an angle. How is that different than cosine of theta equals 3/5? Because technically this has 2 answers. I would like you to right now figure out where you could have drawn that. There's 2 places you could have drawn that. You'd start thinking in 3D, there's 2 places you could have drawn that. Now I'm going to draw the triangle differently when I'm in the unit circle. Not the unit circle, in the using circle trig, because this angle is going to be my 60, adjacent, hypotenuse, and that would have to go like that then. Does that make sense to you? Let's make sure that it does. Cosine is adjacent over hypotenuse. Yep, looks right to me. Taddy, was there another quadrant where I could have actually drawn that?
Well, there's the take out the bottom.
Nice.
Right, but
A-S-T-C. So let's just process this for a minute. Could this have still worked? Could this have been, well, that'd be -4, but we didn't even have that in our problem. We had a 3 and a 5. So, yeah, this has actually got 2 answers. It's just because of context that we only wanted the angle that was less than 90. But there could have been 2 answers to the original question. But as soon as you change it to an inverse cosine, please tell me I taught you that you only get 1 answer, right? Okay. And it'll always be an answer under 90. Think about that for a second. In a triangle, you're always going to want an answer under 90? That make sense? In a right triangle, at least? Okay. All right, so now, what did you do yesterday? You had have a problem like this. We'd say inverse cosine of 1/2. And your first step was supposed to be to go, okay, I know there's rules about this. So everybody take this and write it as cosine of the angle equals 1/2. And that's got 2 answers. So we got to say but, because if you just leave it right there and you just solve it, you'll get 2 answers if you do it right. So you need to tell yourself, but since this is inverse, where was inverse cosine allowed? Think for a moment. You need to recall it from your own brain. It'll increase your retention of it if you recall it right now. Where was inverse cosine? How many of you have a strong enough short-term memory that you remembered it was in one of those two quadrants? Raise your hand if you knew that. Okay, awesome. So these are out, and this is both out. And then since cosine is positive, then they're down to only one. That's out too, because cosine would have been negative there. Remember the all students take calc? Only sine would be positive there. So I'm left with only one triangle. It's got to be there. And cosine is adjacent over hypotenuse. 1, 2. Oh, I know this one. 1, 2, 3. We're going to usually give you ones that you know. And you'll go, I know that's a 60. So then the answer is 60. Or pi over 3. Okay, so how is this different than circle trig? Circle trig would have started with this and would have got 2 answers. Here we start with an inverse trig question. And we only get 1 answer because of all those restrictions. Okay, so here's the restrictions chart. Inverse cosine, we just said, goes from here to here. Put all the rest of the restrictions on this little chart. Inverse sine only goes from here to here. Inverse tangent only goes from here to here. Don't forget there's 2 zones that I told you about yesterday. I'm going to pause for a minute while you fill out the restrictions from yesterday. Okay. Lauren, give me a restriction.
The third quadrant is in the zone.
All right. You'll never do a problem in here if you're doing an inverse trig question. Okay. Opal, give me another restriction.
The fourth quadrant is the negative zone.
If you get an answer in there, it will be negative. Oops. Neg zig. Neg zone. All right. It's 2 more restrictions. Henry.
Sine is from pi to negative pi.
Oh, you're close.
Pi over 2 to negative pi.
There you go.
And it is touching.
And sine touches versus the other one? Say the other one since you knew the difference.
Tangent.
All right. Where is it from?
From pi over 2 to negative pi 2 also.
But,
It does not touch.
yes, because inverse tan is got asymptotes, and the asymptotes won't allow you to touch those 2 spots. Okay, cool. Those are all the restrictions. So now, here's again a question from yesterday. I give you a problem where you need to draw a picture of it and stuff to get the answer, but you're going to have cosine inverse of 4/5. And do you have already got the sides of the triangle? And you can always figure out the third side of a right triangle. So I already have all the sides. When I figure this out, what have I got? Okay, see if you know this, say it so I can act like somebody knew this. All right, then this is an angle and nobody knew that. That's an angle. When you're done with that, it's an angle. I've already got all the sides of the triangle, so that must be about the angle. And then if I do tangent of it, I'm doing tangent of that angle. So do I ever actually need to find out the angle? No, because I'm going to do tangent of the angle. All right, so my advice on this is whenever you're doing these, immediately make all the restrictions. Like, oh, I know this is inverse cosine, so I'm only going from here to here, and cross off the other 2 right away, so there's no chance of you using this by accident. Okay? You could have crossed off the dead zone because it's just not applicable, ever. Then, figure out where cosine would be positive because these are both positive numbers. Then, rewrite this as cosine of some angle is equal to 4/5. Then draw the triangle in the right spot and then figure out the tangent of it. And I know some of you are already done because it isn't that hard. Raise your hand if you are already done. That's about a third of the class is already done. I'll pause for a second while you give this a shot. And when you are done and your neighbor's done, please compare. So check and see with them if they're already done. Okay, so you should have drawn it right here. And I always make the angles kind of like nebulous, like I don't make it long and skinny. I like try to keep the sides to be all about the same. And then when I label them, I just trust that they are what I say they are. Cosine's adjacent over hypotenuse, 4, 5. Ooh, I know this one. It's the 3, 4, 5. Know what I mean? It has to be because it's a right triangle. Or I could have done this and gone 25 minus 16, and then I'd be like, oh, square root of 9 is 3. Okay, then what do I really want? I want the tangent of that angle. This angle's tangent. Tangent is opposite over adjacent, which is 3 over 4. So the answer is 3/4. Final answer, 3/4. Raise your hand if you had 3/4. Cool, then you get inverse trig. So how does it get harder? Imagine for a moment that we had, let's do inverse sine this time, of x. And then I want tangent of that. I feel like this isn't that hard, but a lot of people don't see that this is actually two sides, x over 1. So you can label two of the sides of your triangle, and therefore, can't you figure out the third side? Yeah, even though there's a variable involved, you can figure out the third side. All right, so draw this in the right place. You should know where inverse sine is even allowed. That'll narrow it down, and there'll be only one place where you can draw this triangle. Hint, when there's a variable involved, always draw it in the first quadrant. Okay, then, yeah, that's enough hints. Give it a shot. If you fail, at least you'll know what part you didn't know. Okay, so here's how it should have looked to start with. I know this is the first timer for you, so I'm not going to ask you to show to the other kid next to you. Remember, always try to make your triangles about equal side lengths so it doesn't feel, you know, like weird when it's long and skinny, and maybe it feels like you're supposed to have an 80-degree angle in a spot that's really small. So anyway, trust me, make a average looking triangle. Sine is opposite over hypotenuse. That's got to be 1. Okay, so then this has got to be square root of 1 squared and x squared, and it's not the longest side, so we don't add them, we subtract them. So, and can you tell which one is bigger, 1 or x? Yes, because what? Because variables are always smaller than 1, or why? Because it's across from the 90-degree angle, it has to be the biggest side. Very good. So that's going to be 1 squared, which is, of course, 1 minus x squared. No, you couldn't put the x in front, because then that would be giving you a smaller number minus a bigger number, which would mean square root of a negative, so that would be impossible. So there we go. And when I tell you that when you've got all the sides, you're pretty much there, it's because you're pretty much there. You just need tangent now. And TOA is opposite over adjacent, which is this one over this one. So your answer for this is x over square root of 1 minus x squared. Who had that one right? Sweet! You guys are getting this way better than you're supposed to be getting it. It's kind of freaking me out. All right, so let's see if you remember the domain and range of these things. But you know what really matters? The range, because that's what we put on that drawing. Okay, so I want you to start with just the range. You know, that drawing that goes like this, and we say, oh, it goes from here to here, that kind of thing. That's the ranges of them. Another way to say it is, figure out regular sines domain of that little drawing we drew, and it'll be the range. So, take it off the restrictions chart. All right. And then everybody try to figure out arc cosine and arc sine with a negative there. What in the world is going on there? They only gave us one side. And what the heck does arc mean? Hopefully you know some of those things. I taught them yesterday. All right. I'm going to pause for a sec while I give these 3 questions a shot. McDougall, can you tell me the where inverse sine is allowed?
Like on that up there,
Just answering the range of inverse sine.
the main is -1 to 1, and the range is -pi/2 to pi/2.
Negative pi over 2
Brackets.
to pi over 2. That's from here. Oops, sorry, that's pi over 2 to negative pi over 2. And so, yeah, it's in there. And brackets meaning it can touch. Nice. Inverse cosine. Goldsmith, you want to do that one?
0 to pi.
0 to pi, brackets. And Goldsmith, finish off with tangent.
Negative pi over 2 to pi over 2. That's parentheses.
Nice. Parentheses because tangent can't touch those. All right, you guys should have all tried arc cosine. That means cosine with a little -1. And that's inverse cosine, and that's got restrictions. So it's like cosine of the angle equals 1/2, but it's got restrictions because cosine is only allowed here to here. So then these are out. Cosine can't be negative, so that's out. Drawing it here. This was positive 1/2, so adjacent hypotenuse, that's going to be square root of 3. That's a 60, and therefore pi over 3. Raise your hand if you had pi over 3 for that one. Okay, good. Opal, I'm going to have you try this hardest one, number 3. Tell me what I should do.
I started it, so first I drew out the circle,
Okay.
and then I eliminated quadrants 2 and 3.
So these are out. Has to be from here to here. Then what?
But you know that it's negative, so it has to be in quadrant 4.
Nice. Can't be there because it's negative. And arc really means what?
Inverse.
Yep. So it's an inverse sine question. That's why those restrictions. Okay, now I'm drawing a triangle. Now what?
So I figured that the only one that could be negative was the one going down.
-4.
-4, and then sine of -4 is really over 1.
Yep.
So I left the hypotenuse as 1.
Nice. And then the last side, save me some time. Square root of, it's got a 16, it's got a 1.
So 15.
Square root of 15. And so what's the actual answer?
I'm not sure.
Okay. So remember, these are angles. So it's the angle that would be right there. You have figured out the setup for what angle would be right there. Now, you haven't memorized the 4 root 15 1 triangle, right? So we don't know that angle. What do you think we should do, Alec?
Could you do the law of sines?
Okay. Interesting thought. That's no. 3 sides of a triangle won't, you can't use the law of sines to solve a problem whether you have 3 sides.
But you know there's a 90-degree angle, right? Could you?
Okay, yes and no. Here, what we're saying at the end, though, is that if you wanted to get this answer more than drawing the picture, sine is opposite over hypotenuse, and we need to know this angle. Like we already know the sides, we got all the sides. If we want this angle, you're going to have to use a calculator to get it. Unless you have some magical way that I can't think of, which is possible. Oscar?
Just hypothetically, couldn't you set up like sine? Oh, never mind.
Okay, here's what I would type on my calculator. Inverse sine of -4. And it would tell me the answer. Like, you can get the angle, but you're going to need a calculator to do it. Yes?
Would you not have the hypotenuse be smaller than the one side?
Ooh, that's an interesting point. Wait a minute. Sine is opposite over hypotenuse. Oh my gosh, you have found it. That is the answer to this question, is that there is no answer. And in fact, that's better than saying, I could use a calculator. If you did type that in the calculator, you know what it would say? It would basically say no solution. I can't do that. Because you're right. You can't draw a triangle where the hypotenuse is bigger than one of the sides. And besides, when is sine ever going to go down to -4? That's what it means. Sine of some angle has to get you down to -4. What's the lowest sine ever goes? No, sine goes to lower than 0. Sine goes down to -1. So, thank you for catching that, Alec. This one's a no solution. I knew that we couldn't get the answer, but I thought it was because we couldn't use a calculator. And yeah, you make a really good point. That's just not possible. All right, so these are more problems like this, and which of these is not like the others? Which of these have we never done before? Number 2. Everybody zoom in on number 2 here. Arc cosine of 2/3 plus arctan of 4/3. Wow. And then you have to take sine of all of that. That's almost like sine of two things that are being added together. Do you remember that identity sheet? It's back. Yes, you're going to have to use the identity sheet for this next test. Because unless you have memorized what sine of something plus something is, sine of sine, cosine, cosine, and there's a plus in between. I think I got it, but I'd need to look it up on the sheet to be sure. Then this is telling me my first angle. This is telling me my second angle. And do you get that this would be on the sheet for wherever sine of something plus something is? Do you remember this? Is it ringing a bell? All right, I'm going to pause for a second, see if I can find those sheets. So Jack looked it up, realized Mr. Serva's having an off day today. It's not sine, sine, cosine, cosine. It's sine, cosine, cosine, sine, and those can be reversed, but so why don't you read it right off the sheet so that we're less confused.
Sine x cosine y plus cosine x sine y.
All right. Sine y. Okay. Well, that'd be great if I only knew what x and y were, but I do. This is the x, and this is the y. And so, once again, we draw a picture for this. I'm drawing a picture for it. And where's inverse cosine, arc cosine? Allowed, up here, crossing these off. Is it positive? Yep, it's positive. So that means that it can't be here, and it must be here. Cosine's adjacent, hypotenuse. And is it a 1, 2, 3 triangle? No such thing. Square root of, let me think, 9 minus 4, so square root of 5. Okay, and now I need to do, this was the x angle right here. This is for x. Little x would technically be Elon's child's name. Little x. It's his nickname, actually. There's a little x right there. And there's your triangle. And that'll tell me what sine of x is, won't it? Look at that. Sine is opposite over hypotenuse. Root 3 over 5. Thank you. Must add coffee. Times cosine of y. Okay, so now I got to draw the y triangle. That's for this. That's your job. Everybody try to draw tangent with 4 and 3. Inverse tan, it's only allowed in certain places. Since it's positive, that narrows it down even more. Draw the triangle in the right spot, label the sides, figure out the third side. And this is your y drawing. And that'll be able to answer what cosine of y is. Then you'll be able to finish by figuring out cosine of x and sine of y. Okay, so now my y drawing. Inverse tangent is only allowed from here to here, and it can't touch. Sometimes that matters. Next, it's positive. See, these numbers are positive, so it can't be down here. So now I'm going to draw it right here. TOA is opposite over adjacent. 4, 3. And this must be square root of 4 squared is 16 plus 3 squared is 9. Oh, it's a 3, 4, 5 again. Yay. Okay, so now I've done all of that, and technically that's an angle, but I want cosine of that angle, and this is the y angle. Little y right there. Okay, so now I go cosine of y was where I kind of got stuck. I needed to know y first. So now cosine of that is adjacent over hypotenuse, and so that's this 3 here over the 5. And next is cosine of x. I can go back to this triangle where my x is, and cosine in there is adjacent over hypotenuse, so 2 over 3. And last but not least, sine of y. Sine is in this triangle. Sine is opposite over hypotenuse, so 4 over 5. And these always have a common denominator. It's kind of cool that way. And if they don't, you did something wrong. So then it's a plus in here from that. And so now it's over 15. And on the top, I have 3 root 5 plus 4 times 2 is 8. 3 root 5 plus 8 all over 15. Who beat me to that? Had it on their screen before I said it. Okay, awesome. All right. That was kind of intense. You needed info off a sheet that even the teacher didn't have memorized. And once I knew that, I had to draw 2 separate triangles, one for the x angle and one for the y angle. After that, though, once I had the triangles all done, it was pretty easy. It was just sines and cosines. Sine of x, cosine of y, etc. Okay. We're going to skip over this last one and get to different types of questions. So, I'd like you to try this top one. It's root 3 over 2. Don't let it freak you out that it's sideways. It's just like that. Pausing. Okay, I guarantee you there's some kid in the room who thinks this is an inverse cosine question just because we've been doing a lot of them. Do you see an arc in the problem, or do you see a little -1? No. So, what does that mean? That means there's 2 answers. Don't assume you're doing inverse trig just because we did some recently. Okay? So cosine, students take calcs. Cosine's positive on the 2 on the right. So I have 2 possible triangles I can draw. Cosine's adjacent over hypotenuse. I know this one, 1, 2, root 3. Therefore, I'm dealing in 30-degree angles because, you know, it's across from the smallest side there. And so the answer is 30, aka pi over 6. And the other one is, are you tempted to say negative pi over 6? That'd kind of be good because that means you would know that if we were doing inverse trig, it would be negative pi over 6. But we're not doing inverse trig right now. There was no arc. So it's a whole bunch of pi over 6s. 7. No, not 7 pi over 6. A lot more than that. What is it? 11 pi over 6. Good. All right. But that's not Well, I mean, that's it. We're good. But that's not where we're going to leave it. The two answers were pi over 6 and 11 pi over 6. Yay. If this had been an inverse trig question, which of those would actually have been right? Hint, it's always the smaller one. So, say it if you know it. Pi over 6. Inverse cosine would only been allowed up here. And it's always the smaller of the two angles. If you have two angles to choose from and you're doing inverse trig, it's always the smaller one. It's the one that's going to be less than 90. Okay. So how is this different? Look at the problem. It's pretty much the same problem. It's just that there's a 2 there. Do you remember the u substitution? Let u equal 2x. And then we would have solved it just like a normal problem, which we just did up here. We just did that. We just solved it and we got our two answers. It's pi over 6 and 11 pi over 6. So yeah, I could go through and draw the whole thing over again and get the two answers, but I'm just going to copy from the top. U is pi over 6 and u is 11 pi over 6. But what's u? And therefore this is really 2x equals pi over 6, and really 2x equals pi over 6. And how do you think I'm going to get the 2 off of there? We have to solve it, right? I'm going to multiply by 1/2. Or divide both sides by 2 is another way to say that. Final answers. X equals pi over 12 and 11 pi over 12. Yes?
At the beginning of the question, would it have worked if you like divided by 2 on both sides and then multiplied by?
It would not. And that's a great question to ask. I get back here, like right there. Could you have just multiplied by 1/2 on both sides? No, because there's a cosine there. It'd be awesome if these problems were that easy and you could just go, oh, I'm going to times by 1/2 here, times by 1/2 here. That would be like ignoring that cosine's even there. So you couldn't do that. That'd be awesome if you could, but you can't. So what do? You act like this is a normal theta. And at the end, you swap it out for what it actually was, which was a 2x. And you put that in here and here, and then you solve. Let's see if you really caught that. Sine of 2 theta is equal to 1/2. Act like I just said regular theta, okay? So technically what you're doing is you're letting u equal 2 theta, and then you're doing sine of u is equal to 1/2. And you'll get two answers for it because this is not an inverse trig question. They could make it an inverse trig question, but they're not. Get your two answers and try to finish it properly. Okay, pausing for a second. All right, so let's see if you got this right. You should have made your sine being positive 1/2, left you with ASTC. These are out, and you had to draw your two triangles here and here. And sine is opposite of hypotenuse. 1, 2 square root of 3, that's an angle. This is 1, 2 square root of 3, but it's negative, easy to forget that. Okay, then I get my answers, and I can tell this is a pi over 6 because it's across from the 1, so it's a 30. And this must be 5 pi over 6, and those are my answers. But I can't stop there because u is equal to pi over 6, and u is equal to 5 pi over 6. And do you get that u is actually 2 theta? So I got to change this to a 2 theta and change this to a 2 theta. And then at the end, it's really pretty simple. You just have to multiply by 1/2. So pi over 12? 5 pi over 12. Raise your hand if you had that one right. Sweet. All right. Now you know 3/4 of the things that you'd have to know to pass the test, which isn't until several days after break. Okay, so Don't be stressed about the test yet. That's quite a ways from now. Work time. Here's some problems. I don't expect they're going to be super simple. You shouldn't either. But some thoughts. Whenever you see arc, just make it a -1. Next, always give yourself two sides to work with. Next, I don't know if you always do this, but I always write this as cotangent of some angle is equal to √5/1. And then cotangent, where'd that come from? Oh yeah, I can change that to tangent and make this 1/√5. Did you remember that tangent and cotangent are a flip of each other? And now we got it back to a normalish problem. But it's got the restrictions of inverse tangent. Cotangent goes with tangent on that. So inverse tan is only allowed here and here. So these are out and these are out. And I'm going to draw myself some pictures. And these are all positive, so it can't be down here. It must be here. And I think you can do it from there. Once you're done, we're going to do sine of that. On this arc cosecant one, do the same thing. Set it up as cosecant of some angle. And then flip it. Make it into, cosecant is the sister function of sine. So this one will turn into a sine, and this will flip. But remember, we got all those restrictions of inverse sine and where it can be and stuff. All right. And I strongly recommend that you do some practice problems, but I think I've come to the end of what I needed to teach you for today. That's all I got for the video for today.